Another method for solving quadratic equations is the method of completing the square. Typically speaking, this is a method that students tend to find to be a bit more difficult, but it's not a method to sleep on, okay? Because this method is absolutely going to come up when you get to pre-calculus. Right off the top of my head, I can think of circles. So when you start talking about equations of circles, you need to know how to complete the square. So learn it, understand it, practice it, okay? Now, a quadratic equation, let's remind ourselves of this one more time. A quadratic equation is an equation that can be written in standard form as ax squared plus bx plus c equals 0, where a, b, and c can be any real number as long as a does not equal 0. If a equals 0, the x squared term goes away, and the x squared term is what makes this quadratic, okay? Now, we also need to remind ourselves of something we talked about when we were learning how to factor. There's something called a perfect square trinomial, and it is the heart and soul of completing the square, okay? So a perfect square trinomial is a trinomial of the form a squared plus 2 times ab plus b squared, or a squared minus 2 times ab plus b squared, such that a is the square root of a squared and b is the square root of b squared. So your terms of the trinomial have to fit a very particular pattern. The first and last terms have to be perfect squares, okay? So that's the start. First and last terms must be perfect squares. Then if you take the square roots, multiply them, and double it, that has to be the middle term, okay? So for example, if we had something like x squared plus 10x plus 25, this would be a perfect square trinomial. X squared and 25 are perfect squares, okay? The square root of x squared is x. The square root of 25 is 5. If I take 2, that means double it, times 5 times x, so the square root of the last term, the square root of the first term, multiply them. I get 5x, double it, I get 10x. That is the middle term, okay? Those conditions absolutely have to be met. Okay, period. So the first and last terms have to be perfect squares, okay? And then the middle term has to be double the product of the square roots, and you either add or subtract that middle term, okay? If these conditions are not met, it is not a perfect square trinomial. And what is so beautiful about a perfect square trinomial is how it factors, okay? So if a and b are real numbers, variables, or algebraic expressions, then a squared plus 2ab plus b squared factors as just a plus b, where a is the square root of a squared, b is the square root of b squared. So that factors as a plus b quantity squared. And then if instead I had a squared minus 2ab plus b squared, that factors as a minus b squared, where a and b again are the square roots of the first and last terms. Okay, and what we love about this method is this right here, this format allows us to apply the square root property. So we learned about the square root property in the previous worksheet. Okay, so there's a lot going on here. We know what a quadratic equation is. We know what a perfect square trinomial is. And again, the conditions must be met. First and last term have to be perfect squares. The middle term is double the product of the square roots of the first and last terms, and you either add it or subtract it. And then as far as factoring them goes, you're always going to have a squared either plus or minus 2ab plus b squared, and it's going to factor as either the sum or difference of the square root of the first and last terms quantity squared, okay? So let's talk about what completing the square is. So basically, completing the square is the process of converting a quadratic equation into an equivalent equation that can be factored and solved using the square root property. So basically, we're forcing the quadratic to be a perfect square trinomial. And we want to force this because of the way it factors. If we can get a perfect square trinomial, we can factor that quadratic into a single term that has the variable squared. That allows us to then use the square root property to solve. Okay? So we're again forcing this to become a perfect square trinomial, okay? Now, as far as completing the square is concerned, it's a very simple process. So what we would do is if x squared plus bx is a binomial, if we add b, the coefficient of x, divided by 2 squared, That'll give us a perfect square trinomial. That is x squared plus bx plus b over 2 squared is going to equal a perfect square trinomial, which would then factor as x plus b over 2 squared. So this right here is how we complete the square. Okay? So for the very first example, it says complete the square for each binomial, then factor the resulting perfect square trinomial. Okay. Now I do have this note here that is really, really important, and I'm going to tell you about it now. The coefficient of x must be 1 in order to complete the square. Okay, so when we complete the square, we take the coefficient of the linear term, or just x, we divide it by 2 and we square it. Okay, that becomes the constant that forces this to be a perfect square trinomial. For this to work, the coefficient of the squared term must be 1. If not, we have to do more work. That's a later video. Okay, so again, example 1, it says complete the square for each binomial, then factor the resulting perfect square trinomial. Well, for part A, we have x squared minus 14x. What constant would we have to add to this so that it's a perfect square trinomial that we could then factor? Well, we want to take b, which is negative 14. We want to then take b and divide it by 2 and then square it. So that's our end goal. So we've got negative 14 divided by 2 squared. Well, that's negative 7 squared, or 49. This value right here completes the square. So if I take and I add 49, this is now a perfect square trinomial. Okay, and what's so great about a perfect square trinomial is if I take the square root of the first term, so x squared, the square root of that is just x. If I take the square root of the last term, which we've now decided is 49, the square root of that is 7. This sign right here always tells you whether you add or subtract down here. So we're going to subtract, and then we square the whole thing. Okay, and that's what's so magical about this factored form of the perfect square trinomial. So this is the value right here is how we create the perfect square, how we complete the square, and then this is the factored form. So let's do another one. So we have x squared plus 3x. Well, b is 3. We now want to find b over 2 squared. Well, b over 2 is 3 over 2. And then if we square it, we get 9/4. So, ew, we have a fraction. Nobody loves fractions, but it's actually not hard in this case. We want to go ahead and add 9/4 to this binomial. That makes it a perfect square trinomial. And then to factor this, we take the square root of the first term. Well, the square root of x squared is x. We take the square root of the last term. So if we take the square root of 9/4, the square root of 9 is 3. The square root of 4 is 2. And then this sign right here tells us if we add or subtract. We want to add here. Let me fix that plus sign. That just got more and more out of control, huh? So we want to add here, and then don't forget you square the whole thing. And that now would allow us, if we had a full equation here, this would allow us to use the square root property. Okay, so that is kind of what we're doing. That's like what the perfect square trinomial is, how we can apply the square root property, what completing the square means. And then so far, all we've looked at is how we actually complete the square. In the next video, we will talk about actually solving an equation by completing the square.